What is the Marlowe Playground? It's an environment where we can build, analyse and simulate step by step the action of Marlowe contracts. We can do that in a safe environment, so we can check that the contract does what it should do, make sure it doesn't have any bad behaviour without endangering any of our crypto assets. Now, what can we do in the playground? We can open a project we were working on already. We can open a built-in example. We could start a new project using JavaScript or using Haskell. We could use the textual form of Marlow, but let's instead start with Blockly. And in fact, here's a contract that I started writing earlier, but it just allows me to show you some of the features of Blockly. What we have here is we can manipulate contracts as blocks. And if we want to, for example, create a new contract, if we click on the contracts button here, you see all the different kinds of contract that we can build. Moreover, if you click on one of these icons here, you see that correspondingly in the menu are the type of item we need, type of block we need to use to fill in those holes. So it makes assembling a contract foolproof. You can always tell what you need to fit into any particular hole in the contract. Let's just reassemble this and see what sort of contract we've got. It's a contract that waits for a deposit by Alice into her account, and then it waits for Bob to choose a number between 0 and 1, and then it pays to Bob the amount of 1 plus his choice from Alice's account, and then it closes. Now we've also got here a wait. Oops, I've lost that from my main contract. We can wait up to slot 10 for Alice to make a deposit. If she doesn't, we close and refund any money that's in the contract. Similarly, waiting for Bob's deposit, we wait until Bob's choice, we wait until slot 20, and then we do the same thing. And in that case, we refund the money to Alice. But here we've got our contract. Let's send it to the simulator. And let's start simulating. The simulator says there are two interesting things we could do. We could deposit 1 ADA. Let's do that. And then you can see the contract has evolved. Now the highlighted part is smaller. At this point, we could either make a choice by Bob, or we could move to slot 20. Let's see what happens if we do that. You see that Alice gets her money paid back because Bob hadn't made a choice. Let's undo that, and let's make a choice here of 1 and add that. And then you'll see that what happens is that the contract has paid, after that, 1 ADA from Alice out of her account to Bob. But unfortunately, that didn't work properly. We got a warning here. The contract is supposed to make a payment of 2 units of ADA, but it only made 1. And so built into our environment is the ability to track this kind of error. And if we go back to the source, we can do what's called a static analysis, analyze for warnings, and without running the contract at all, we can see that there is this problem. We can reach a partial payment. Now, what's lovely about the analysis is it checks every possible path through the contract. In the simulator, I just happen to hit a bad path. Using the analysis, you can be guaranteed to find a bad path if there is one. So, brief summary: contract building, contract simulation, contract analysis, analyzing for a failed payment. That's, in a nutshell, what you get with the Marlowe Playground.